Hello. Today we are looking at how to set up and implement Modbus RTU slave or server on the AC500 PLC. A little bit of the setup that I have here. I have a ABB AC500 V3 controller using CPU PM5650. I have one digital I/O module here, and then I have an extension module here. It's a CM574. It's a serial extension module. What I want to do today is to set up and establish communication between this PLC serving as a Modbus RTU slave and a Modbus RTU master that will be reading data and writing data to the registers of the PLC here. Now, I mentioned I have this extension module, which is a serial extension module, but I'm not going to be using this. I would use this because it has two ports. You can see it has COM port 1 and COM port 2, so I can use this for my Modbus RTU communication, but I want to use the onboard. So the CPU here, or the PLC here, has an onboard serial interface. You can see it from here, so I can plug it out for you. And you can see that I've wired it up already. So I'm using, for this tutorial, I'm going to be using Modbus RTU over RS232. And I'm going to be using RS232 over 2-wire, so it's a 2-wire connection. So this comes in different configurations. Like you already know, you can use a 4-wire configuration where in a 2-wire configuration, you only have 2 wires. One is for RX, which is receiving data, and then one is for TX, that is sending data. And the middle one here is just the ground. So on the other end of the master, I connect TX, and then it will be RX here, and then I connect RX here to TX on the master side. So that is how it works. So you can have my connections here already established. And just to repeat, for this configuration, RS232 over 2-wire, pin 6 here, as you can see, is the TX pin. So this TX pin connects to the RX on the master side. And then pin 8 here is the RX pin. So RX connects to the TX on the master side. And then the middle one here, the 7, is the ground. So TX, RX, and then a ground here. We shall see later some other serial architectures we can use, things like RS485 and RS422. But for this tutorial, we're strictly using RS232. So I'll plug this back in. And then I'll show you what connection that I have towards the master, so the Modbus RTU master. So I want to use my computer as the Modbus master. And at the end of this wire here, I have this female D9 connector. So if my computer had a D9 port, that is a male D9 port, I'll just plug in and then establish my serial connection like that, and then write my code, and everything would be okay. But my laptop doesn't have a serial port. So what I do is I use this converter here. This is an RS232 to serial, rather to USB converter. It's an A10UC232A. And I use this to convert my communication as it comes here as RS232. Then the converter will convert it from RS232 to USB. And then I would have plug this into my laptop and then have an established serial connection, just like that. And then I can run my Modbus RTU protocol over that. So that is what I'm doing. RS232 from here, then it comes here to this converter. The converter converts it to USB, and then USB. That's how I run my connection there. If it was another PLC, I wouldn't bother with this. I would just take, like I said, the TX to RX, RX to TX, and then ground to ground, and that would be easy. But that's what I'm having here. Okay, I can show you a little bit of the datasheet of this converter as well, just to know how you should connect the cables and which pins represent what, as you see here. And then we can proceed. Okay, a little bit more. So this is the pin configuration or description for this onboard serial interface, like I said already. So you can see we have pin 6, that is the TXD. So transmit data out. Then pin 8 is the RXD, receive data in. And then signal ground is this pin 7 here. And then if we were using another architecture, for example, RS485, then we'll choose different pins as well. So we use pin 1 to 4 there. And then 422 as well. I don't think it's supposed to 422, but 422 would also be another story. And then, like I said, you can use a 4-pin configuration or a 2-pin configuration. And for the 4-pin configuration, then we have two extra connections here. We have this RTS, this is request to send, and then this CTX, which is clear to send. But our case, we're only using these two-pin configuration or two-wire configuration, so we don't need those. And then for the ATEN UC232A, you can see here the pin configuration as well. So pin 2 is the RX pin, so it will connect to the TX on the PLC side. Then pin 3 is the TX pin, so it will connect to the RX on the PLC side, and then pin 5 is the ground. So those are the only 3 pins or connections that we need. Okay, so now we have our connection established and we have everything set up. Now we can go ahead and first configure our Modbus RTU server, and then later we shall use the client to read and write data, or the master rather, to read and write data. Okay, so we have a program that we've been using for in other tutorials, so we are going to use the same program here. So remember, in one video I kind of explained how the register space for the ABB V3 PLCs is set up. So I'm not going to go much into details anymore. I have a buffer here, which I call MB joystick data. So I have this simple program here, which is a virtual joystick. So whenever I move the joystick here, it will record for me the data here. So it will record for me the angle from 0, the radius, the X and Y position of the joystick at any one moment. So whenever I move it here, it will generate for me this data. And then this data is what I want to send over Modbus, or is what I'll make available for a Modbus master or Modbus master to read. So basically what I've done is I'm storing this data in this buffer here. So you can see I have the X position, Y position, radius and angle. And then I've mapped this buffer to a register address. So you can see it's mapped at register MW0. So that's the very first register. And this is an array of 4 elements of type word. So that means it will occupy 4 registers starting from this register. So it will occupy register 0, 1, 2, and 3. So that means that if my master, Modbus master, accesses this register space, then it should be able to read that data because I've mapped the buffer there to that specific register space. Okay, so now we have our data and we've mapped it to the register space of our interest. Now we can go ahead and set up this communication. So the first thing you want to do is so we have the onboard stereo interface here. So you see it's this COM, it's empty now. We want to attach a device. So you right click on this, go to add object, and then you want to attach this COM1. So you want to attach a communication port there. So click on replace, and then we have a communication port attached to our interface there. Attach a Modbus slave, Modbus RTU slave on this serial COM port. So again, right click, add object, and then you'll see that you have two options that you can select here. So you have an RTU client and an RTU server. So like I was saying, these terms sometimes used interchangeably. For example, when we are talking about Modbus here, sometimes they say server, client, and then master, slave. So master, slave, and server, client is almost the same thing. So here, server is the device that is hosting the registers, and then client is the device that is reading or controlling the communication. And then for the master, slave is also the same thing. So master is controlling the communication, and then slave is the device that is hosting the registers that are being read by the master, something like that. So here what we want to add is we want to add this server. So you can see we click here and we say replace. So we want to replace the device with this Modbus RTU server. And then we've done, and now we're done with that. The next thing we want to do is to configure this COM port. So our communication parameters. So the first thing you want to do is to select which serial architecture you're using here. So you can see that you have a few options that you can select. You can select 232, you can select 485, and then CS31 bus, but we want to set it to 232. The other thing you want to select now is the communication or the band rate here. So can remain at 19,200. Parity none, we're going to use 8 data bits and then 1 stop bit. And then no flow control because we are not using the request to send and clear to send connections. So if we were using those, then we would select, you can see hardware RTS and CTS. But since we are using a 2-wire connection, we don't have flow control, so we'll leave that at that. And almost that's it basically. Now all we want to do is now to upload our program and then test it out. Okay, now my program has finished uploading, and so you can see what I was talking about previously, how my virtual joystick works. So whenever I move the joystick, it gives me the current X position, Y position, the radius from the center, and then the angle respect to 0. For this demonstration, I'm going to use a Modbus RTU master simulator. So this is the COM port for the RS-232 to USB converter. So this is what I should use here. And I'll open up my Modbus RTU master simulator here. I need to set up my serial communication properties. So comport 3, like we saw there, the bound rate is 19,200. It should correspond to what I have on my PLC. On the other side, data bits is 8, stop bit is 1, parity is none. And then we don't have this RTS option. So we are running a 2-wire communication over RS-232. So we don't have the RTS and CTS. So that is disabled as well here. I click OK, and then now I should start to read some data. So I select RTU here. I want to read holding registers because, like I've already demonstrated, this mapping is for holding registers. So holding registers and input registers use the same address space. So I can either read holding registers or I can read input registers as well. But I want to read holding registers here. Then I want to read 4, starting from address 0. So remember we said we've mapped to the very first address. So that is address 0. And I put 0 here, and then I want to read 4 of those registers. And then now I should start connect, and then start reading here. So now everything is 0, but when I start moving my joystick, then I should start seeing some data coming in. So what I would do is I'll move this. I'll make it small. Let me see what I can do, because I want to see both of these here. Maybe I can pull this. Oh, actually, what I can do is I can take out this like this, float it here, and then I have the master here on this side. Now, when I start moving the joystick, how did that work? It just goes away. Okay, let's see what we can do with this. Okay, this should work. So you can see when I start moving the joystick, then I have the corresponding values on my master here. So I have the X, Y, then I have the radius, then I have the angle. So that's how this is working. So now I'm reading data from the Modbus server slave there, Modbus RTU slave, and then I'm reading that over serial. So this is Modbus RTU communication. So this is just reading, but you can also write registers, so it doesn't really matter. But I think that's it for this quick demonstration here. I hope you enjoy it. Thank you and have a nice day.